You are in the meeting now.
Recording in progress.
Is anybody there? Good morning. Host, how are y'all today?
Good, how are you?
Doing well, doing well. Um, Post. As far as I can tell, y'all are the only ones connected right now. Oh, there's Sudan. Hey, Sudan, how are y'all today? All right. I guess Plains is not in school today, or there's no students in class today. Nonetheless, um, welcome to week 11. As far as announcements go, um, our next, let's see, what do we have coming up? Okay, so this week, wow, stuff is happening this week. Um, Let me get my notebook. All right, wow, snuck up on me. So, this week, we are concluding Unit 3. So we have three assignments, 19, 19, 20, and 21. Those three assignments, we conclude Unit 3, and exam 3 is going to be next week. I have exam 3, part 1 and part 2 set for um, Monday and Wednesday of next week. Um, and then we'll meet on Friday, where we begin looking at assignment 22. Um, so that's the current schedule. Uh, I will get the unit review up in for unit 3 up in the week 11 folder. Let me write that down. Um, during week uh, so week during week 12 we have exam 3. During week 13 we're only going to meet on that Monday. That's Thanksgiving week. And then after that we have 2 full weeks of school. And then in that 2 weeks we'll do a review for our final exam, and then we have the final exam. Wow, this semester is wrapping up quick. Um, so the purpose of today is to address any questions that you have over assignment 19, properties of logarithms, or if there's any still lingering questions over any previous assignments. So, as I like to say, the floor is yours. How can I help you with any questions that you may have over assignment 19 or any other previous material?
Can you do number 9 on assignment 19?
Problem number 9.
Also, we can't see you, so
Is this Sudan?
Yes.
Yeah, so you're still having that technology issue. There's nothing I can do about that. As I was telling your facilitator, um, I um I sympathize with your situation, and I can't wait for things to be resolved. Um, Y'all do know that you have access to the recorded video once the link goes up on YouTube, correct? You know about that?
We try to access it, but we don't see it on YouTube. We only see the lecture videos.
No, the recordings, the recorded videos. Not the
No,
live
sir.
stream, but the recorded videos.
No, sir. We don't know where those are at.
Oh, well, I talked about it at the beginning of the semester. If you go to course resources, in the left menu bar, there's a link at the very top that says class recordings, and it has all the recordings of the semester.
Yes, sir. Thank you.
So, as I told your facilitator, I know that y'all can't see me right now, and that's very unfortunate. Um, it is what it is, and so we just have to deal with it until it gets resolved. Only thing I can do is just tell the person in front of me about the problem, they'll tell the person in front of them, and so forth and so forth. So, anyway, let's go back to your question. Problem number 9. I will do my best to explain this verbally as I go through and do this. Alright, so problem number 9 from assignment 19. We want to expand the natural log of, alright, so we introduce a bracket and a division bar. In the numerator of that division bar, we have a 5x squared with a square root of 3x plus 1. And in our denominator, we have a 2 open parentheses x plus 1 close parentheses to the third power. Alright, so when you go through this process of expanding, anytime that you have a division bar, a fraction bar, what you wanted to start off doing is you want to start off by expanding this by looking at how do you make that division bar go away? How do we separate this out? So I'm going to use the quotient rule to expand this. So we're going to have the natural log of, and in parentheses, I'm going to put my numerator. So natural log, open parentheses, 5x squared, square root of 3x plus 1, and then close parentheses. And since we're using the quotient rule, that means we're going to introduce a subtraction sign, subtract the natural log of our denominator. So I'm going to put minus natural log, and then in parentheses, the 2, introduce another set of parentheses, x plus 1, close parentheses cubed, and then close the parentheses around the 2x plus 1 cubed. So now you should have 2 logarithmic statements. And now what we're going to do is we're going to start expanding each one of these logarithms. So let's begin with the first logarithm, natural log of 5x squared square root of 3x plus 1. And since we are multiplying the 5, the x squared, and the square root, we can use the product rule to expand this into 3 separate logarithms. So we have the natural log of 5 plus the natural log of x squared plus the natural log of the square root of 3x plus 1. Now, I haven't done anything with that second logarithm. Now, this is where you got to pay very close attention to this expansion of the natural log of 2x plus 1 cubed. There's a minus sign in front of it. So what I'm going to do to remind myself that that minus sign distributes is I'm going to put my expansion in a set of brackets. So I'm going to put minus sign, open a bracket, and then put the expansion of the natural log of 2x plus 1 cubed. So that becomes in a bracket, or a set of parentheses, whatever you want to do, natural log of 2 plus the natural log of x plus 1 cubed. That x plus 1 is in parentheses, by the way. And then I'll close my bracket. And I do this so that I take note that that minus sign is going to distribute to the two natural logs that are in my bracket. Alright, now at this point I've used my quotient rule to basically break apart that fraction, and I used my product rule to expand those logarithms, and now I'm going to be looking for any opportunity to use the power rule. So remember, the power rule takes the exponent that's inside the logarithm and it brings it out in front of the logarithm as a coefficient. So I have the natural log of 5, can't do anything with that. But then with the natural log of x squared, I can use the power rule to bring that exponent of 2 out in front of the logarithm. That gives me plus 2 times the natural log of x. Then I have the natural log of the square root of 3x plus 1. We can rewrite the square root as an exponent of 1/2. So I can now have the natural log of, in parentheses, 3x plus 1, close parentheses, raised to the 1/2 power, which in the next line of work, I'll bring that 1/2 out in front of our logarithm using the power rule. Now let's distribute our minus sign. So that becomes minus the natural log of 2 minus the natural log of x plus 1 cubed, which there I see, oh, I can bring that 3 out and put it as a coefficient in front of the logarithm. And so now I think I got it. One last line of work. Natural log of 5 plus 2 natural log of x. Bring out that 1/2. So you have plus 1/2 times the natural log of 3x plus 1. A quick note, make sure that you put the 3x plus 1 in parentheses, because you're indicating that that is what you're taking the natural log of. Minus the natural log of 2 minus 3 natural log of, in parentheses, x plus 1. And there is our final answer. That is this problem fully expanded. So speaking specifically to Sudan, I know that you can't see my screen, which is rather unfortunate, but were you able to follow along with my voice and what I was stating as I went along?
Yes, sir. The only part I didn't understand was whenever you put the second part of the natural log in parentheses. So you subtracted the natural log of 2, and then you said you subtracted 3 natural logs of x plus 1.
Yes.
Why is there a negative right there?
So the reason is, at the very first step, you need to use the quotient rule because you have a numerator and a denominator, right? In the numerator, you had the 5x squared square root of 3x plus 1, and in the denominator, you have the 2x plus 1 cubed. You with me?
Yes, sir.
So when you use the quotient rule, you're going to have two logarithms that are being subtracted. So you're going to have the natural log of the 5x squared square root of 3x plus 1 minus the natural log of our denominator, 2x plus 1 cubed. Now that minus sign in front of the natural log of your denominator, because you're about to expand that natural log of 2x cubed, x plus 1 cubed, that minus sign is going to affect that entire expansion. So imagine if I'm going to do a very simple example, and I'm going to write this out for the students to see as well. Let's suppose we start off with a negative 6. This is just a very simple example explaining what I'm saying. So write negative 6 down. Now, in parentheses, I'm going to say this is equal to, I'm going to put a negative sign, and then I'm going to open a set of parentheses, I'm going to put a 2 plus 4. So negative 6 is equal to a negative open parentheses 2 plus 4. Now what is that minus sign going to do? It's going to distribute. So that's equal to negative 2 minus 4. So that's why there's a minus natural log of 2 and a minus natural log of x plus 1 cubed. Because the minus sign in front of it, before you expanded, will have to distribute to the expansion. Does that make sense?
Yes, sir. Thank you.
Alright, I'm glad I was able to verbally talk about that. Alright, so that's why you have the minus natural log of 2 minus 3 natural log of x plus 1. Alright, what else can we look at?
Can we go over number 3?
Number 3. Yes, we can, certainly. Alright, let's find number 3. Alright, so sounds like I'll just remember again to be very verbal about how I talk about this so that y'all understand. Problem number 3, we want to condense. We have the natural log of, in parentheses, a 2x plus 1 minus the natural log of 3 plus the natural log of y minus the natural log of a z plus 2 minus the natural log of 5. Alright, so, you know, it's been over a year since I made these videos, so I don't exactly remember how I approached this, because there's more than one way to approach this problem. And again, I don't remember how I approached it in the lecture videos, but I find that there's a very straightforward and simple way to approach this, and hopefully it will make sense in light of problem number 9. And what I'm going to do is I'm going to do some rearranging. I'm going to rearrange some terms. And basically what I'm going to do is I'm going to put all the positive terms together and all the negative terms together. So in terms of positive terms, I had that natural log of 2x plus 1, and I had the natural log of y. So all I'm doing is I'm rearranging things. And then I'm going to put my negative terms together. So I have a minus natural log of 3, a minus natural log of a z plus 2. Hold on just a second, everybody. I'm going to actually just sit down for a second. Jermaine, just sit down. Everybody else, y'all are fine. So we have minus the natural log of z plus 2 minus the natural log of 5. So, natural log of x plus 1, natural log of 2x plus 1 plus the natural log of y minus the natural log of 3 minus the natural log of z plus 2 minus the natural log of 5. What I'm going to do next is we're going to so that we're doing the same thing let's just go ahead and take care of the positive terms. These two terms at the beginning can be condensed together using the product rule. So we can rewrite the first two terms as one term, the natural log of 2x plus 1, and we're going to multiply that by a y. And that's one term. Now, here's what I'm going to do next. I'm going to factor out the negative from the last three terms. Since every single one of those last three terms has a minus sign in front of it, we can factor out the negative. Then in a set of brackets, I'm going to put those three terms in their positive form. So we have minus, open bracket, natural log of 3 plus the natural log of a z plus 2 plus the natural log of 5. Now, the reason I do this is it cuts down on a number of steps that you have to do if you just went from left to right, condensing. Because now what I can do with those three terms that are in my bracket is I can combine those together with a product rule. So you still have the natural log of the 2x plus 1, close parentheses, times y, minus, now I'll put these in brackets again, but let's condense those three terms so that you now have the natural log of 3 times the z plus 2, that z plus 2 is in parentheses, times 5. Now you should see that, I have a natural log of something minus the natural log of something. That can be condensed using the quotient rule. Quotient rule. So this now becomes, I'm going to move up here. We have the natural log of, we're going to have a division bar. In the numerator, I'm going to put that 2x plus 1 times y. And in my denominator, I'm going to put the 3 times the z plus 2 times the 5. And one last thing that I can do to make this even more simple is we can multiply the 3 and the 5 together to give us the natural log of 2x plus 1 times the y 15 times a z plus 2. And I'm done. And that matches the answer key. Um, there might be a couple of questions like, how come we don't distribute the y, or how come we don't distribute the 15? And I suppose the best way to say why we don't do that is I'd rather have a product of quantities in my numerator and in my denominator rather than a summation or a difference of quantities, if that makes any sense. Alright, so Sudan specifically, I know that you can't see me, but do you have any questions over that?
So if we were to distribute the y or the 15 on an exam or a quiz, would that be counted wrong?
No, I'm not going to count it wrong, because technically I'm not going to count it wrong. I would just say that is not, it's not required. Does that make sense? It's not required. And again, the basic idea is you would, it would be, think about your calculator work. If you were typing something into your calculator, you would like to do as few operations as possible to get the job done. So, just for a quick example, it would be easier to just write everything out as a product of things rather than a summation of things in your calculator. So I'm not going to count it wrong. You will have to make me work a little bit harder because my answer key, like for this example, would stay as 2x plus 1 times y in the numerator. But if I saw 2xy plus 1y, okay, I would say, all right, they did the work. They just went above and beyond it, if that makes any sense.
Yes, sir. Thank you.
You're welcome. If you'll excuse me just for a quick second. All right. Sorry about that. What else can we look at? Are there any other questions over assignment 19? Anything that I can help y'all with? Planes, how are y'all doing? Or is it Post? Post, how are y'all doing? I can't tell, sir. Is that a thumbs up? All right. So I should restate this. The camera is too low, and when you do your hand like this, it goes above the camera. So is that a thumbs up? Like, do it right here. Thumbs up. Yeah, thumbs up. Okay. Yeah, when you're doing it, I couldn't see it because the camera feed was going up above like that. Are there any questions I can help y'all with over the homework?
Can we do number 7?
Number 7. Who is this? Plains or Sudan?
It's post.
Post. Post. Sorry, I keep getting y'all mixed up. Alright, it's post. Alright, problem number 7. We want to expand the log of, we have a division bar, we have x squared y cubed over a z to the 9th. Okay, so like I said with problem number 9, anytime that I have a division bar in my, y'all probably want to see this, don't you? Sorry about that. So here's problem number 7. And as I said in problem number 9, anytime that you have a division bar inside your logarithm and you're expanding, you want to use the quotient rule. So we're going to expand this so that we now have the log of two quantities. We have the log of our numerator, which is the 2x squared y cubed, minus the log of our denominator, which is a z to the 9th. Okay, so that took care of our quotient rule. Now, what I see in that first expression, that first term, we have the log of an x squared times a y cubed. So I can expand this using my product rule. So that becomes the log of x squared plus the log of y cubed minus the log of z to the 9th. Alright, are you with me so far? Good so far? Post?
Yes, sir.
Alright, now I'm seeing all of those exponents. Exponent, exponent, exponent. This means that I get to use my power rule, which says that I can bring those exponents out in front of each logarithm as a coefficient. So we now have 2 log of x plus 3 log of y minus 9 log of z. And there is our answer in its fully expanded form. Does that make sense?
Yes, sir.
Great. Okay, what else can we look at?
One S.
I actually have a question over
Yes.
assignment 18.
Okay, let me get to assignment 18. Yes, what is your question?
Um, I'm not understanding number 24, H.
24H. Okay. Alright, so, let's see. Get that back up. So, going back to assignment 18, we're looking at problem number 24H, where we want to evaluate 10 to the log of 5, and we want to do this without a calculator. Now, there are properties that will tell us what this answer is. And one of those properties that we have, I forget what the name of it is, but it goes something like this. B to raised to the log base B of x is equal to x. And here's the reason why. Let's talk about why. And better yet, let's talk about why the answer to this problem is 5. Why is the answer to 10 raised to the log of 5 equal to 5? Here's what we're going to do. Let's just suppose that you don't remember any of the properties, but you remember, the one thing that you do remember is that you remember that y equal to the log base b of x is equivalent to b to the y equal x. Do you remember, the one thing that you do remember is you remember that correlation, that relationship between logarithms and exponents. That's one thing that you remember. Well, let's use that one thing that we know and work backwards. So I'm going to take that 10 raised to the log base log of 5, and I'm going to set it equal to, it doesn't matter what you set it equal to, let's set it equal to x. It could be set to any variable that you want. Now what you have is you have an exponential expression. Now, yes, there is a logarithm, but that logarithm is in the exponent. You have a 10 raised to some power is equal to something. So what we're going to do is we're going to take this exponential expression and we're going to rewrite it in the logarithmic form. So what does the logarithmic form look like? Well, as a quick review, 10 is going to be our base. And in the logarithm, if you're going from the exponential form to the logarithmic form, what the exponent is equal to is going to be what you take the log of. So since we have 10 raised to the log of 5 is equal to x, x is what we're going to be taking the log of. So we can rewrite this as, you can further state this, you can further state that the log of 5 is what the, is going to be what the log equals. So you can rewrite this now as log base 10 of x is equal to the log of 5. Now you're two steps away from determining what x is. What we have to remember, what we have to be thinking about is the common log and the natural log. Recall that if you have the log of a, that's the common log. That's the same thing as the log base 10 of a. So it doesn't matter which one you rewrite. I'm just going to rewrite this as, I'm going to keep that log base 10 of x, but since I just have log of 5, I can rewrite that as the log base 10 of 5. And then basically it's just using just saying, well, what does x have to be? You have the log base 10 of x is equal to the log base 10 of 5. So what does x have to be? X is 5. So if x is equal to 5, that means way back there up at the very beginning of the problem where we set 10 raised to the log of 5 equal to x, we can now say that 10 to the log of 5 is equal to 5. And all I did was I used my property, used a relationship between exponents and logarithms to answer the question. Or I remember the property that says b to the log base b of x, or b raised to the log base b of x is just equal to x. Alright, so Sudan, again, I know you can't see me, but did that make sense?
Yes, sir.
Okay. Good. What else can we look at? What else can we look at?
Can we look at number 16 on assignment 20?
Assignment 2016. Yes. Wait, assignment. Say that one more time. I got mixed up.
Question 16 on assignment 20.
Question 16 on assignment 20. Alright, so we're looking at exponential equations.
Yes, sir.
Okay. 16, correct?
Yes.
Alright, so looking ahead, which is fine with me. I don't mind looking ahead.
Your conference is scheduled to end in 2 minutes.
We'll see what we can do in the next 2 minutes. Assignment 20, problem number 16. We have e to 2x minus 2e to the x minus 3 is equal to 0. So the first thing I recognize is that if I do e to the x and I square it, that gives me e to the 2x. So that means I'm going to use a u substitution. I'm going to let u be equal to e to the x. Then this becomes, since u is equal to x, then u squared is equal to e to the 2x. This becomes u squared minus 2u minus 3 is equal to 0. I just rewrote that exponential equation as a quadratic equation. So I'm going to solve this quadratic equation, u squared minus 2u minus 3. This will factor so that we have u minus 3 times u plus 1 is equal to 0, which then means that u is equal to 3 and u is equal to negative 1. Now, remember, what did we say u was? U was equal to e to the x. So you have two statements now. You have e to the x is equal to 3, and you have
Your
e
conference
to
is
the x
now over. Goodbye.
is equal to negative 1. I will finish this problem on Wednesday. Only one of these works. Only one of these will work.